I'm Pete Stevens. I'm director of Mythic Beast Limited. I also own VM House, which is a much smaller Lynx member. And in about half an hour, we'll find out if I'm on the board or not. I've preemptively replaced you with a very small shell script. So, I saw on a website called LinkedIn a job offer, which said, I'm on the lookout for a junior network bod to help with data cleanse, make sure our config management DB matches what's on the live network and correct all the discrepancies. I think this is about a 3-month contract. Anyone interested, get in touch. And I thought, yes, that's the job for me. No, that's not what I thought. I put my management hat on. It's like, you need someone with some valuable skills, which is how networking works, to do something extremely tedious and boring, which is auditing your network. It's also disruptive because every time you find a discrepancy between your config database and your production system, you either have to fix your config database or fix your production system. And this also includes a bunch of archaeology. Why are they different? What do I have to do to fix it? If I make production match our config database, will that go and disconnect someone's service? Can I fix our config database to reflect what's actually in production? Does it know how? So, yeah, this is pretty painful. And even more than that, there's a bigger problem, which is why is production different to config management in the first place? And there's 2 schools of thought here. You've got the DevOps school of thought, which is config management knows everything. It's only allowed to be in production if it's in config management, and that means when you have an emergency fix, you have to wait for your development team to write some software, go through a continuous integration build and deploy it, which is really a pain in the neck if people are screaming at you on the phone because it's broken right now. Or alternatively, production is the source of truth, and you've kind of permanently got this problem. And the other problem with this case is 3 months to audit is enough time for yet more drift to occur. So as soon as you finish, you need to start again, and we're painting the 4th road bridge. Really what you want to do is audit your network every day, even every hour. That would be pretty cool. So we started automating it rather than employing people to read config. So the first thing you discover is all the standard nice useful tools you've got for managing text files and source code don't really work. Things like IPv6 addresses can be written in multiple different ways. Things get reordered because your BGP daemon might not think the order of things is important. So basically, when you type show running config, you may not get out exactly the same file that you put in, and you need to work out what to do. And the other thing is anyone who's successfully employed routing security has discovered that your prefix list can change about every 30 seconds as various networks around the world add and remove prefixes. So they're never going to match. So we've got a series of configuration files that pretty much describe our network. We've got a routers file, routers.yaml. YAML is a markup language that's like XML, easier to type in and has just as many ways to shoot yourself in the foot really easily. And it knows about all of our networks and all of our IP addresses. It knows about our customers. It knows about our internet exchanges and our transits. So you can poke this and you can go build me a BGP config. And it will go, oh, I found 2 routers that share a subnet. So there's a connection between them. Let's rewrite all the BGP config and make them talk to each other. And it's got a customers file, again YAML, which knows about customers who take BGP from us, and so it will work out which customers are viewable by which routers where, and again, magically generate all of the config to make it go, apply prefix filters, route filters, and so on. This is all good. We've also got a static file for people who have statically routed things inside our ASN, and again, we can just magically generate the config. You just fill in, here is a customer, they're on this VM, here's their network block, and it just goes and writes your network config for you. We also have a peers file, which is tab separated for historical reasons. Don't tab separate your files, that's not a very good idea. That really needs to become a database and get automatically filled in from PeeringDB, because at the moment we keep having to manually copy and paste things, which is very annoying. And that's because PeeringDB doesn't quite have every piece of information you need to set up a peer. For example, for some reason, it doesn't know the MD5 passwords that people like to use. But from that, anyway, we can build our entire peering config, all the sessions for a peer, all the route filters that we build from our ADB, and we can automatically update all of our route filters on an automated basis. This is all good. At this point, we can generate our BGP config from a set of text files and spit out what we think should be running. And then you diff this against your production and you get an absolute shed load of errors. So what you have to do is write a context-aware diff that can go to your running config and then turn it back into what your generated config would look like for things that have the same value, which is canonicalizing your IP addresses, reordering things, and so on. We check prefix lists exist for everyone we peer with, but we don't specifically check the contents because we know that our biggest peers will have changed on every run of our diff. And the net result of this is we can order a router really, really quickly. Including building prefix lists, we can do an audit in about 30 seconds, and that will give us a list of lines that are in production that our config management database doesn't know about. And this gives us a very nice fast audit loop where you say, what's the config on this router? Why is it wrong? You get a list of lines back. For each one of those, you keep bashing away at it until either your config management database knows what it should be doing, or your production router no longer has the wrong config in it. Keep going until no errors. When you've done that, schedule this to run all the time, and every time something drifts, you get emailed about it. Why is this a good idea? Well, we caught a bunch of fat finger errors. One of the things you'll notice there, and as a major IPv6 advocate, this is one of the reasons why IPv6 is really annoying, the addresses don't easily scan. So we put the wrong next hop in 5 years ago and didn't notice because it turned out the next hop was another valid router, but we lost all of our redundancy in one of our sites for years without having realized because config auditing is really dull. So why do we do this? We know what config we're actually running. If someone monkey patches something in at the last minute to deal with an urgent problem, we get notified. We can find out about it, which means we can then go and tell our config management database to fix it or undo the monkey patch when it's no longer needed. So it doesn't prohibit us from doing under duress, the world is on fire, please make my network just work. But it does prevent you from forgetting about them, which is really useful. However, it's not just networks, we do other things too. So every day we get an email from our VM audit, which says, in this case, I've just found a virtual machine called Maryland in Amsterdam, and I don't know who's paying for it. Which is good from our point of view. Well, it's bad that we've got a VM, we don't know who's paying for it, but it's good that at least we know we've got a VM that nobody's paying for. Online chat room, someone's like immediately, right, okay, who messed this one up? And it turns out it was cancelled the next day. AVF is a guy called Alex. He's a relatively new member of staff. And it turns out our procedure for how to cancel a VM under special circumstances wasn't clear enough, and he didn't clean it up properly. We caught it the next day. Everything is back to happiness. This is all good. So this sort of heads you to infrastructure of code. So this is a picture of one of our racks, which is built entirely from our config database. So the machine at the top is called Leprechaun. It's a Mythic Beast because we're Mythic Beasts Limited. And that tells you what Leprechaun is, where it is, what its asset tag is, what all of its connections are. And one of the things you'll notice about Leprechaun is it's got an awful lot of serial connections, and that's because it's the serial server for the rack and it's doing out-of-band management for all the other machines. Hipsters beware. We use Perl. Really sorry for those of you who are Python or Ruby or Scala or Go or whatever fanatics. We use a lot of Perl. And that's our config file format for our infrastructure database is actual Perl. So we call functions like add asset, and you can put loops in, like for my port 1 to 8, loop there and add 8 ports on, which is quite nice, or really horrible depending on your point of view. Add connection is a function that you call which says plug a virtual wire in between these two things, and then our database then knows about it. So from here, we can now do a bunch of auditing on our infrastructure. So we have compile time checks. So when you say build a copy of our infrastructure in the database, it says, aha, your network socket has 2 network wires in it. I don't think that's true. And it can do things like make sure that your connections actually have both ends plugged in. And our asset tags, B numbers, are self-checksumming, like credit card numbers, so we can spot typos. And we can do checks like, does everything that need a connection actually have one? So if a device has a power socket, do we know that it is plugged in somewhere and what it is plugged into? We can also do dynamic checks. Do our devices have DNS records? Are they actually powered on? Because we can ask the power bar. Is the switch port up? Is this thing listening on the network? Do we have an up switch port where we don't know what's connected? Because we know where every single wire should be. And so as a result, we can now do a full audit every single week on a Monday morning. And that generates a bunch of tickets which say things like switch 7 in rack 19 in Sovereign House data center, port 23, something's plugged in, send a person to go and find out what it is, because we don't know. And similarly, and so the result of this, if you unplugged everything in our network and put it in a pile, we could probably put it back in exactly the same place it started. So if you have little kittens, that will solve your problem. This also feeds into cross-system integration. So we have power graphs for all of our power bars. We know who is connected to each power bar. We can do aggregate graphs for people. We get summaries for our racks. We have graphs for all of our switch ports, and we can summarize them based on transits and internet exchanges and so on. And all of that is just automatically done. So cron builds all of our MRTG config. So when we added a transit provider, our transit graphs automatically updated and included them in the summaries because it's all built automatically. In our control panel, we can take an asset tag, and from an asset tag, we can discover where the switch port is, where the power port is, serial port, network address, your bandwidth usage, and I'm missing a picture. You should get a picture of the rack with the thing lit up in red to say it's here, so you can actually physically find the thing when you're in the data center. This links through to our billing database. If we don't have a billing record, we don't have automatic config, and your service won't work. So we learned this back in 2007 when we became a full-time operation, when we discovered that we hadn't billed 1/5 of our customers ever, because we'd set them up and left a note that said, remember to bill this customer and not charge them. So it turns out that's not just us. We bought Blue Linux in 2012, who had exactly the same problem, and we bought bhost in 2018, who were better. They were down at like 2% of their infrastructure had never been charged for, which was better than 20, but this keeps happening. So you need to make sure that everything you actually have, you know who is paying for it and vice versa. So this results in our control panel that populates itself. So B0012KOK is a really exciting name, which is one of our servers that's in Amsterdam. It's got some IP addresses allocated to it, some v6 addresses. It has a magic button that says power cycle that you can press, which will switch it off and on again, which is fed from our assets database. It's got a recovery mode, so you can upload an SSH key there, tell it to reboot from the network, and it'll come up in Linux on the network, so you can remotely go and reinstall your entire machine. It's got a serial console, which makes this much easier to do, so you can do remote provisioning, remote install, and as you can see from the console output, this one is a VM host with a guest that's doing something naughty and generating vCPU at 0 errors. Feeding through further than that, there's also a little thing that's appeared there called graphs, because this server has a management service attached. We charged you for something, so therefore magically something happens. So we get little graphs of what the server's actually doing and how busy it is. It's also generated a set of monitoring. So we've got ping, SSH, and web monitors. One of the things we discovered as a managed service provider, you say to a customer, we'll monitor your server, what does it run? And they tell you it runs a service, and then they add a bunch more services to it, and then one of them fails, and you don't notice because you didn't update your monitoring because your customer didn't tell you about the additional services it's running. That happens all the time. One of the solutions to that is to say, it's not in the contract, not our problem. The other solution to that problem is we automatically port scan every single managed customer every single day in order to find services that they've enabled and not told us about. And we automatically configure all the monitors for those, so if someone forgets to set up monitoring, it gets done for you. And that way, we will tell customers usually that they've just switched off an SMTP server they enabled by mistake, and we've had an alert raised because they suddenly enabled SMTP, we thought it was a production service, and then we go back to them and say, your SMTP service has gone away, and they're like, oh yeah, that was a mistake. But yeah, it's all magically built. And so the graphing is Munin, open source package. We build the config from our database, DHCP recovery environment, so you can randomly fix things remotely. That's done. The monitoring is done. For HTTP and HTTPS services, the problem there is you don't necessarily know what domain name you need to be monitoring, and you don't necessarily know automatically what the config, what the content is on the page. So in that case, it automatically generates customer support tickets for us, which say, someone started a web server on this managed server, go and have a look at the web page and generate a monitor, so alert us if it changes. And how do you do this? Internal plumbing. Paul, one of our co-founders, everything should be REST. REST is really nice to work with. SSH force commands are really horrible and end up with a massive pile of awk, sed, and xargs. Meanwhile, Toby, our other employee, said everything should be an SSH force command, because we already use SSH for all of our admin anyway. And if you have a REST API, you've now got to run a web server, and you've got to manage a secure certificate, and you've got to do authentication, and it gives you a separate config, and so on. This is really annoying. Great. Two utterly irreconcilable options. Or are they? What you can do is basically implement a REST API over SSH. So SSH provides the transport for passing data back and forth. You SSH into a machine, and it gives you JSON back, which in its own way is really kind of horrible, but actually is a really neat solution to the problem. So here's an example on our Raspberry Pi cluster from a while ago. You can log into the Raspberry Pi cluster and say /unused, and it comes back and says, I've currently got 41 free Raspberry Pis ready for anyone to rent. And the other one there is you can go to my Raspberry Pi and tell it to reboot, and it will, and because we're Unix geeks, we return null if things succeeded, because that's what proper commands should do. So we've got a set of SSH APIs, so it's very easy to say, go and connect to this REST service over SSH and do some things with it. We use SSH for admin everyway, so every single machine we have already has SSH enabled, and all of your admin is managed in a single place. We have SSH, FP, and DNSSEC, which means that we have key management working. So when you deploy a host, the SSH key goes into DNS. You can trust the result from DNS because we have DNSSEC. It turns out this does not work anywhere near as well as it sounds in theory, but we're slowly getting there. And this feeds into managed updates. We've got thousands of managed customers who want security updates. We've got Debian, Ubuntu, CentOS, various stable versions of all of those. The customers have all got root on all of their servers and can install their own packages whenever they feel like it, and they don't have to tell us and fill in forms first. They might also be using something like Puppet, Chef, or Ansible, or another made-up config management tool that we've never heard of. So whilst everyone will say, treat your servers as cattle, not pets, that's brilliant in theory, but we run a cattery, and it's a luxury cattery. So, yeah, what we have to do is we see updates come through. So we see a critical update for Apache. You know, there's a 0-day remote exploit in Apache. We've got to update it as fast as we can. So we just need to run apt-get install Apache 2.2, possibly Apache 2.4, or possibly yum update HTTPD, depending on exactly which flavor of server we've got, and there might be variants on those various commands that you get, depending on what this particular customer is running, and we've got thousands of them. So, once upon a time, we installed a standard SSH key on our customer servers, but that's a security nightmare. Someone nicks your key, they can log into everything. One of your staff members leaves and takes the key with them, you've got to go and rekey every single customer server. That's no good. Now we do a key for every single customer, sometimes more than one key, and we've got a central jump box that has all of those keys. Our staff members can log into the jump box and request a session on a client machine, but they can't get the key to log in directly. So it's a single point of access that makes managing our staff easy and allows us to do role-based access control in a straightforward way. The other thing you have to remember here is you have to switch off agent forwarding, otherwise people can log from a client machine, nick your authentication token and go and log into another machine. So there's two levels of protection here. Firstly, agent forwarding is off by default, and secondly, every customer has a different key. So you can't agent forward from one customer to another, you can only go within a customer. So this feeds into our bulk update process. So you start off saying Apache is broken, management bulk update, and it says, hi, I'm going to make all of this work for you. And then it asks you for some extra options, which include things like, which data center would you like to update? Are there any customers you want to exclude? Do you specifically only want to do some customers? For a typical 0-day, that's update everybody as fast as you can. For our monthly bulk update, we do one data center at a time. So people who have services in multiple different data centers get patches at different weeks. So if the patch happens to break their service, it doesn't break the backup service at the same time. Flip side, of course, is occasionally you have slight package differences between production and disaster recovery. That's a square the circle problem. But anyway, you pick your options, and then our code sits there and goes and builds every single supported operating system we have, works out what package updates you need to meet the requirement, and then it goes and searches our entire estate to find every single customer who's got a vulnerable package. When it's done that, it then writes an email for every single customer to explain which machines we're about to update and exactly what packages we're about to update, including any and all dependencies, and gives them a date of when they're going to do it, which is usually 7 o'clock on a Thursday morning for scheduled updates, or right now if it looks like openly exploitable 0-day in a listening service. Then you say, I'm happy with the message that's been generated. You can edit the template if you want. And it goes and emails all the customers to say, we're about to do an update to your service. And then the next instruction is do the updates. So you say yes. Our code parallelizes and starts updating up to 40 machines at a time, successfully logging std out, std air from every single machine so it's trackable to work out where it is. So that way, if anything goes wrong, you've got the logs of what actually happened. This often takes some time, depending on exactly how many customer machines you've got. 30 seconds an update, 30 seconds to a minute an update means you're rocking out a machine a second. If you've got a couple of thousand machines to update, that's a good hour or so before it will complete. And this will apply all of the updates, and then at the end of it, it then does a further audit stage, not that I bang on about automated auditing or anything, where it goes back and logs into every single one of those machines again and checks that the package update it's got now is the one that has the security update applied to it. And most of the time, you will get one or two machines where the customer update didn't go through for some reason or not. It asked a question, there was a config change, or something didn't happen, and then you've got a list of which machines you need to go and manually attend to patch up the last remaining difficulties. And then it says, congratulations, you finished. Archives the entire directory, so if someone comes back in 2 weeks' time and says, why did you update my server on this date? You can say, it was this announcement, we sent you this email, we've got a full audit trail. And the result of this is a 0-day update for a single package we can do in about an hour. A monthly update for a single data center is a smaller number of machines, but more general bug fix packages, which is about 90 minutes. We learned the hard way to limit to 40 servers at a time. When we were younger and smaller and a little bit more stupid than we are now, we decided to do all of them simultaneously. If you go and update every single virtual machine sitting on the same physical host at the same time, you discover that you don't have enough CPU or I/O for that to complete, and they all fall over. Don't do that. That would be my advice. Here's an example of one of ours. This was OpenSSH in Debian Jessie only, fortunately. We audited a couple of thousand machines, patched 486 of them. 8 of them needed manual investigation for reasons that I can't quite remember. And we were about 90 minutes start to finish for SSH is no longer vulnerable. And anyone who runs SSH as a public listening service would probably panic quite a lot about having a vulnerable SSHD with known exploit in the wild. So that's kind of where we start, but it kind of keeps going. We have whole domain name purchasing that automates OpenSRS and Nominet. DNS, we have a nice control panel for managing bind for people who don't want to write their own config files, which also has an API for people who do want to automate having us write your config file for you. DNSSEC, anyone enjoy doing their DNSSEC rollout? Ooh, all the hands. Wow, that's one more than normal. Yeah, and DNSSEC, we automated that, and I've certainly forgotten how it works because I have no wish to ever remember. And so, yeah, hosting accounts, Apache, Dovecot, Exim, all this configuration just gets built, and basically everything starts in the billing database, and some code goes, da-da-da-da-da, you've bought a service, congratulations, it's working, have an email to explain what's going on. We've got a couple of container builds as well, where we scripted LXC on Debian without using Docker, because we think persistence can be useful, and keeping your data across reboots can be nice. Another thing we have is a thing called Reporter, which is our magic time travel piece of software. If you've ever been handed an undocumented machine and someone said, it's broken, can you fix it? You start typing commands in like netstat, what network connections are listening? IP tables, what does my firewall say? What's my process list? And all sorts of things like that. What disks do I have? Are my disks broken? Do I have a RAID card? Is my RAID card up to date? And things like that. And so what Reporter does is it basically types in every single one of those commands every day, and then centrally logs the output. So when you're handed a broken machine that your customer has just broken and says, fix it, you can find out what it was doing yesterday when it was still working, which is really useful. And all this stuff basically has the same set of building blocks. All the communication is done with SSH. That sorts all the authentication and encryption for you. Mostly we've got Perl, we've got a little bit of Python, a little bit of Go, a tiny bit of Haskell, which probably wasn't the good idea it seemed at the time. Most of our data is stored in Postgres. We quite like our data and we'd like to keep it, which is why we put it in Postgres. And for our tools, we create Debian packages or RPMs that just fit into your standard operating system. So you can just go apt-get install Mythic utilities, and it installs all the things you need to do a managed server, which nicely interacts with other people's content management systems, so config management systems. So if one of our customers uses Puppet, we just say, put in your Puppet config, include Mythic utils, and then all of our management all of our management tools are on the machine. And it also means our tools get updated by exactly the same process that we use for all of our security updates and managed updates, because it's all nice and straightforward. You just go apt-get, upgrade Mythic utils, and off it goes. So ideally, what we do is we get a request from the customer and we work out how to do it once and write down what we did so we can remember how we did it. And then we turn that into a manual procedure to kind of standardize it. And as you get a few people who start doing it, you start automating bits of that procedure to make it quicker to do, just to save your own time. And at some point, you get to the point where it's only a couple of commands to deploy an entire thing. So Let's Encrypt is a great example of that. It started off with, how do I get a website that automatically updates its SSL certificate? And turns into, I need to run 2 commands on a server, and it now has secure certificates for all the websites hosted on it. And then the next step is you build it into your control panel and your operating system package, so it just goes in by default. And then the next step is really good. You can just go to the pub and forget how everything works. And sometime later, you go back to your billing database and discover you've got 1,000 people buying a service. And you've got completely standardized rollouts of common things that people want. All of our different things are at some different point in this process. I'd like all of them to be at we have 1,000 paying customers. We're not quite there yet, but we're getting there. So yeah, that's a quick summary of how we try to automate everything and how we manage quite a lot of customers with very few staff. You can find out more on our blog. We're also on Twitter at MythicBeasts, and you can even email me. So thank you very much, and any questions? I gave this talk at UK North, by the way, so Neil asked his questions at a previous time, so that's how I got out of that one.
Still hasn't got it right.
It's just a quick one around bootstrapping of physicals. Sorry,
Yeah.
I'm Richard from IPI. Do you have any documentation on how you're bootstrapping physicals at all? Are we talking to ILOs or Drax or anything else, and how you're then bringing that into configuration management?
So when you get shipped a new server, you plug a screen and keyboard in briefly and enable serial BIOS and tell it to netboot. Then you just tell our config database what the MAC address of the machine is, and it'll boot Debian off the network with the right set of customer keys.
Okay, cool, thank you.
Excellent.
Thank
Yep.
you.
Thanks very much, Pete.